Hello, and welcome to the Object Particle Spawner tutorials. In this video, we will demonstrate the collision functionality of the system with and without rigid bodies. Our scene begins with two identical standard Unity particle systems. As you can see, both particle systems have their trajectory going through a mesh collider wall in the background. For the rigid body collisions, we start with a basic primitive cube object in the hierarchy, which could be a prefab as well. We assign a tag to the cube and attach a default box collider, rigid body, and object particle component. The object particle component must be attached for rigid body collisions. For the particle collisions, we start with a basic primitive sphere without any colliders or rigid body attached. Now we can feed these objects into our object particle system. Let's create an object particle system component for the rigid body collisions. We will only inherit movement and enable the release on rigid body collision option. Here we will set ignore tag to the cubes tag so that the cubes do not register collisions with each other. Then we disable recycle on release option so the objects don't recycle into the object pool. Then we drag in our cube and give it a spawn weight. That's it for rigid body collisions. Next, we set up the particle collision system. We begin by adding the object particle system component. Again, we inherit movement, disable recycle on release, and feed our sphere into the system with its own spawn weight. This time, we enable the Unity Particle System's collision module instead of using rigid bodies. We set its collision type to world, and you'll notice the particle system colliding with the wall on the left. Hit play to see these changes in effect. You'll notice the box is being released from the system when the rigid body collision is registered with the wall and rigid body gravity behavior takes in effect. On the left, the sphere's collision is controlled by the Unity Particle System and continues on the particle path. These collision mechanisms work for both 2D and 3D implementations in the same way.